Hi everyone, today we are going to study the circuit matrix. Before studying circuit matrix, we have seen how we can draw an incidence matrix for a graph, and the incidence matrix basically tells about the incidence between the vertices and the edges. In the circuit matrix, we will see how we can represent the circuits of a graph in the matrix form. Now let the number of different circuits in a graph G be Q. If there is a connected graph G and it is having circuits, so if I assume the total number of circuits to be Q in that connected graph G, and the number of edges in that graph G are represented by E. So that means if the total number of circuits are represented by Q and the total number of edges of the graph are represented by E, then a circuit matrix represented by capital B. So B here is representing the circuit matrix of the connected graph. In that case, B is equal to Bij of graph. This Bij is representing elements of the circuit matrix. So elements of the circuit matrix, that is various coordinate positions wherein there will be different elements at different coordinate positions of the circuit matrix, and this Ij, that means the row and column, it will be a row by column matrix representing various elements at various coordinate points or coordinate positions of the circuit matrix. It will be Q by E matrix. Q by E means the rows will be represented by the total number of circuits. So the total number of circuits are basically the rows here, which is I, and J, which is the column, is the total number of edges. Since this is a Q by E matrix, so I will be, that means I, which represents the rows, will represent the total number of circuits in the graph, and J, which is the columns, will represent the total number of edges in the graph. So it will be a Q by E matrix, which is also known as 0, 1 matrix, because at any given point of time the elements of the circuit matrix will either be 0 or 1, wherein 0 represent the absence of a condition and 1 represent the presence of a condition. And since here we are looking for circuits, so it is quite obvious that 0 will represent the absence of a circuit in the absence of a circuit, and the 1 will represent the presence of a circuit. So it will be a Q by E 0, 1 matrix defined as follows. Now this Bij, this I is basically your rows which are defining the circuits in the graph, and these J are your columns which are defining the total number of edges of that graph. So Bij is equal to 1 if the ith circuit includes the jth edge, right? Now if that particular ith circuit includes your jth edge, if this jth edge is in this ith circuit, then the element at this particular coordinate position will be 1, and if this jth edge is not in this ith circuit, if this jth edge is not included in this ith circuit, then the value at this particular coordinate position will be 0. So if the jth edge is included in the ith circuit, then the coordinate at that particular coordinate position, the value will be 1, and if the jth edge is not included in the ith circuit, then the value at that particular coordinate position will be 0. So this is how you will represent circuits in the matrix form. Now to emphasize the fact that B is a circuit matrix of G, B is representing the circuit matrix of the connected graph G. So to emphasize this very fact, the circuit matrix may also be written as BG, where B represents the circuit matrix and G represents the connected graph G. So when I say BG, this means the circuit matrix of the connected graph G. So this is one way of representing the circuit matrix. When I say BG, B here represents the circuit matrix and G here represents the connected graph G. So when I write BG together, it says the circuit matrix of the connected graph G. Now let us look at a graph and various circuits in that graph, and then let's see how we can represent those circuits through a matrix, which is your circuit matrix. So if this is a connected graph and there are total 4 circuits in this particular graph, one circuit is the circuit AB, then the other circuit is circuit C, E and G. This is also forming a circuit. This is one circuit. Then CEG, this is second circuit. Then DFG. DFG, this is the third circuit. And fourth circuit, C, D, F and E. This is the fourth circuit. So total there are 4 circuits. C1, this circuit. C2, this circuit. C3, this circuit, and C4, this circuit. There are total 4 circuits in this graph. Circuit AB, circuit CEG, circuit D, F and G, and circuit C, D, F and G. Now how we will represent these circuits in the matrix form. Now first of all, you should know how many circuits are there in total. We have found that there are total 4 circuits in this graph. Now if Q represents the total number of circuits of the graph, that means the value of Q here is 4. And if E represents the total number of edges of this graph, then the total number of edges are 1, 2, 3, 4, 5, 6, 7 and 8. So the value of E is 8 here. And we always consider a Q by E matrix. That means clearly it will be a 4 by 8 matrix where there will be total number of 4 rows and total number of 8 columns, which are represented by in the form of I and J. So when I say IJ, that means I is representing the rows, J is representing the columns. What are the rows? The rows are the total number of circuits in the graph. And what are the columns? The columns are the total number of edges in the connected graph. So it will be a Q by E matrix. That means it will be a 4 by 8 matrix because the value of Q is 4 and the value of E is 8. Since there are total 4 circuits in the graph and total 8 edges in the graph. Therefore, this circuit matrix will be a 4 by 8 0 1 matrix. Why 0 1 matrix? Because in this 4 by 8 matrix, at every coordinate position, you will either have value 0 or value 1. Value 0 when for the for the ith row, there is no circuit at the jth element, and 1 for that coordinate position when for the ith row, there is a circuit at the jth column, right? So let's see. We will clarify this. So BG represents the circuit matrix of the graph G. There are total 4 circuits, 1, 2, 3, 4. I can also write C1, C2, C3, C4 to make things clear. Now there are total 8 edges, A, B, C, D, E, F, G. These are the total 8 edges of the graph. Now if an edge is involved in a circuit, for that particular coordinate position, you will write 1. And if an edge is not involved in the circuit, for that particular coordinate position, you will write a 0. The circuit C1, this is the circuit C1 AB. This is circuit C1, circuit C2, circuit C3 and circuit C4. Now when I look at circuit C1, how many edges are involved in circuit C1? Edge A and edge B. There is no other edge involved in the circuit C1. So simply for circuit C1, I will write the values 1 at the columns for the edges A and B. So for edge A and B at circuit C1, I will write 1 and 1, and rest for all the edges I will simply write 0. Similarly, now let's look at circuit C2. There are clearly 3 edges involved in the circuit CEG. For circuit C2, at the at the columns of C, E and G I will write 1, 1, 1, and rest for all other edges I will write a 0. Now let's look at circuit C3. How many edges are there at circuit C3? D, F, G. So for circuit C3, at edges D, F and G I will write 1, and rest for all other edges I will simply write 0. Now let's look at circuit C4, the fourth circuit or the fourth row. And for this row, which all columns will be having value 1? The columns for the edge C, D, F, E. So for circuit C4, edge C, edge D, edge F and edge E will have a 1, and rest for other columns of all other edges you will simply write a 0. So there is simply write a 1 only for those edges which are involved in a particular circuit, and for rest of the edges you simply write a 0. Like AB is involved in circuit C1, 1 and 1 at the coordinate positions for the edges A and B, and 0 for rest all other edges. Similarly, C, E and G are involved. These three edges are there in circuit C2. So simply write 1 at the coordinate positions for the edges C, E and G for the circuit C2, and for rest other edges simply write a 0. So this is how you can make a circuit matrix for a connected graph. Now there are some observations related to a circuit matrix. What are these observations? These observations are that for a circuit matrix BG of a connected graph G, a column of all zeros corresponds to a non-circuit edge. What is a non-circuit edge? An edge that is not involved in any circuit, or an edge that does not belong to any circuit. For example, edge H is not involved in any of the circuit of the graph, hence it is a non-circuit edge, and you can clearly see for the column corresponding to the edge H has all zeros in it because it is not involved or it does not belong to any circuit. So basically, whenever in a circuit matrix you see a column of all zeros, so such a column for an edge such a column for an edge means that this edge does not belong to a circuit. Each row of the circuit matrix is a circuit vector. Like this row is a circuit vector, this row is a circuit vector, this row is a circuit vector, and this row is a circuit vector. Unlike the incidence matrix, a circuit matrix is capable of representing a self-loop. Whereas in an incidence matrix, you cannot represent self loops through the incidence matrix, but these self loops can be represented through a circuit matrix, because a circuit matrix is here to represent circuits, and a self loop is also a circuit, right? The number of ones in a row is equal to the number of edges in a corresponding circuit. For example, in this particular row, if you see the row for a circuit C1, if you look at this row, there are 2 ones in this row. So that means clearly there are 2 edges involved in the row corresponding to this circuit. So when you look at circuit C1, there are only 2 edges involved, hence there are only 2 ones in this row. Similarly, if you look at the row for circuit C2, there are 1, 2 and 3 ones. That means there should be 3 edges involved in the circuit C2. So if we look at circuit C2, we can clearly see that there are 3 edges C, E and G involved in the circuit C2. So that means for any row, the number of ones in that row is equal to the number of edges in the corresponding circuit which that row is representing. If a graph G is disconnected, this is the connected graph. But again, the same thing, that if the graph is disconnected, then in that case, obviously it will consist of 2 components which in themselves will be connected. A disconnected graph will consist of 2 components which in themselves will be connected. If I assume there is a disconnected graph, then it will be having 2 components G1 and G2. So G1 will be connected in itself and G2 will also be connected in itself, right? So If you want to represent the circuit matrix of these two components which are connected graphs in itself, then the circuit matrix for the connected components of a disconnected graph can be written in the block diagonal form like this, where BG would represent the circuit matrix of the components of the disconnected graph, and you can represent in the block diagonal form like this, where BG1 represents the circuit matrix for the component G1 and BG2 represents the circuit matrix for the component G2. So you can draw a circuit matrix for the components of a disconnected graph like this in the circuit matrix form, and the circuits in G1 will have no edges belonging to the circuits in G2. Similarly, the circuits in G2 will have no edges belonging to the circuits in G1. So this is how you can represent or you can draw a circuit matrix for a graph.